So this is the third part of the probability question from Business Maths 1 2013 MA 4102. A sports shoe manufacturer makes shoes at two locations. 70% are made in Yangon and 22% are made in Mandalay. Now just as a quick remark, those are the only two locations, and 78 plus 22%, that accounts for 100%. Okay, that's an important mark. So we've accounted for all of the locations. So there is a 3.5% probability that that a pair of shoes made in Yangon will be returned to the vendor within a month, and there's a 4.5% probability that a pair of shoes made in Mandalay will be returned to the vendor within a month. Now, find the probability that a pair of shoes chosen at random will be returned to the vendor within a month. So it doesn't really matter where they come from. So we'll look at this one first, and we'll just read through the question here and just sort of make a few remarks actually. So the first thing we're going to do here, just to put that back, the first thing we're going to do there is remark that the 75% probability that a 78% probability that a shoe comes from Yangon. So we're going to call that event Y, and that is, so if a Y shoe comes from Yangon, which I believe was recently called Rangoon and Burma. So probably shoe comes from Yangon. So the probability of Y is 0.78. And M shoe comes from Mandalay, and probability of M equals 0.22. So that's so far so good. Now this bit is where things get more interesting. There's a 3.5% probability that a pair of shoes made in Yangon will be returned. Okay. So first off, we're also actually interested in general about the probability of return. So we're actually going to name this event R, and shoe is returned. And actually this question asks us find the probability of R. Okay. But let's just sort of think about that piece of information that we're given about returns. There's a 3.5% probability that a pair of shoes made in Yangon will be returned. Now this is the important part of the question. So what is this? This is this part here. It indicates conditional probability. So how we can sort of might rephrase that is probability of being returned given that it comes from Yangon is 0.35%. 0.035%. That's an important step there. So the probability of return given that it comes from Yangon equals 0.035. Now this is an important step there. So this here requires a very careful idea about how to write down conditional probabilities given a written description, how to write them down mathematically. So again, R given Y, return given that it comes from Yangon. Now the questions are always deliberately sort of rephrased in a different way, so just to sort of try and test you a bit. So that's actually what we're particularly interested in, probability of R given Y. Similarly, we're actually also interested in probability of R given M, which is from Mandalay, that is 0.045. That's the other piece of information we were given. Now, this is those four values that we're given, PY, PM, and PR given Y, and PR given M. We've enough there to find out what we're looking for, and remember, this is what we're looking for. Probability of R is equal to what? Okay. I'm going to say two things here, and it's actually what I'm going to sort of say is we have two locations for shoes. Okay. So the shoes can either come from Mandalay or they can come from Yangon, and that's it. So if a shoe gets returned, it comes from Mandalay or it comes from Yangon. So we can actually sort of split the return shoes up into two groups. So I'm going to write this here. So the probability of return is the probability that it gets returned and that it comes from Yangon, plus the probability that it gets returned and it comes from Mandalay. Now these are two mutually exclusive events, disjoint events as well. Okay? So the probability of R is the probability of return from Yangon plus the probability of R and returned from Mandalay. And it's either one or the other or both. So essentially, like if you look at it, consider all return shoes, we can split them up into two piles, the ones from Yangon and the ones from Mandalay. It's a sort of very simple idea like that. So this is going to help us break down the answer here. So I'm going to go on to the next slide here, and we're going to look at these two statements here. Okay. Now, remember I sort of said something there about the conditional probability formula. Let's look at that there again. So probability, this is how we would use the conditional probability. Probability of A given B is equal to, hang on a sec, pen's jammed up. Probability of A given B is probability of A and B over the probability of A. But we can actually re-express this formula here. We can multiply both sides by the probability. We can actually sort of rearrange this formula essentially. So that we can say the probability of A and B, probability of A intersection B, is the probability of A given B times the probability of A. I messed that up there actually, sorry. It is probability of A given B, and that's times the probability of B. So that's, sorry, I just misquoted there. That's the conditional probability formula, and that's how we can rearrange it. So probability of A and B is equal to the probability of A given B times the probability of B. So let's remember what we could sort of say here. What we're interested in is probability of from returned and from, let's say, Yangon. That is equal to the probability of returned given that it comes from Yangon times the probability that it comes from Yangon. So we actually have this value here, which we were told directly, and we have this value here that we were told directly also. So we actually can use that. I'm actually going to go to the next slide again, and what we can say here is that probability of, we'll actually write in the other one as well, probability of returned and from Mandalay is the probability that it got returned given that it came from Mandalay times the probability that it came from Mandalay. Okay, and we can put in all our values here now. So the probability of it being returned and from Yangon, that was equal to 0.035 times 0.78, and this is that's from the last slide. And using this one here, probability of returned and from Mandalay equals 0.045 times 0.22. So let's calculate those. A little bit of calculator work here. So working that out, we get, let's change the color here, 0.0273, and the second one here is 0.0099. Okay, so when we add them together, probability of R, which is equal to this one and this one added together, that is equal to 0.0273 plus 0.0099, and that is equal to 0.0372. So that is the answer to the first one. What is the probability of a return? And the answer is 0.0372, or in other words 3.72%. Okay. Now, given that a pair of shoes is returned to the vendor within a month, find the probability that it was made in Mandalay. Now, this is very straightforward about how to calculate. So this is actually, just if you think about the question, it's a conditional probability question. I'm just going to go to the next slide here, and what I'm going to say is this: that the probability that it came from Mandalay, given that it was returned, is what we're being asked here. So I'm just going to slide up here a second, and let's have both on. That's not it. Hang on a sec. So let's just slide up here a second, and there we go. Given that a pair of shoes is returned to the vendor within a month, find the probability that it was made in Mandalay. So given that it was returned R, find the probability that it came from Mandalay. So probability of M given R. Now let's just use our conditional probability formula here again. That is equal to probability of M and R divided by the probability of R. Okay. Now, just as a quick remark, we actually know this already. We just actually calculated there a minute ago. We also know this because, again, we just calculated a minute ago. Probability of M and R is equal to, just check, it is equal to, just like, am I pressing the wrong buttons here? 0.0099 and 0.0372. So 0.0099, probability of R, just there you can see that at the top of the slide, 0.0372, and we're going to divide one by the other. So let's divide that out, get rid of that equal sign. And so this is now just turned into a very simple calculation. Divide 0.0099 by 0.0372. And we get 0.2661, 26.61%. Okay. So that ends this presentation.